Hello YouTube, let's keep going with this programming language. So in the last video I talked about using traits, and I think it's not really necessary. I mean, one place where it could be necessary is, or where you could use it, is that we have all these things that evaluate. But on the other hand, they don't really necessarily value to the same thing, but probably you could still use a trait. But right now we only have, say, the expression that we want to evaluate and also the statements. So I think it's not really necessary. Instead, let's just keep going. So now we kind of handle print statements. Now we probably need to handle assignment statements. So what we do now is define or redefine the grammar. Before we just had a series of statements. Now instead we have a series of declarations. And a declaration is either variable declaration or statement. And it should look like this, which makes a lot of sense. And now an identifier is also like a primary expression. Okay, so the first thing we will need is another type of statement here, and like in the book we will call it a var. And now we need the token struct. So we'll call it name as a token, and it will have some initializer. So like something like this is the idea. Okay. And we also need to allow it in the expressions. Kind of the same thing. Okay, and now we should go and fix up the parser. So first we need to get not a statement but a declaration, and the declaration should also just return a single statement. And simply try to match the var token. And if it matches, we will return a variable declaration. Otherwise, we will, it's a catch, right? So basically, we should do this to match what the implementation in the book is. Let's say that we actually get a statement out. So that will just return that. If we get an error, we'll actually ignore the error. No, we won't ignore it. We won't ignore it, but we will start by calling synchronize, and then we will return it. And there's no else right now. And we don't have that function yet. We're finally ready to hook up error recovery. So our error recovery works a little bit differently. So if we get an error, we synchronize so we get to the next statement that we can reasonably read. Then we return the error, so the error message gets put onto this list of errors. Okay. And I just forgot how to read Java code. So if it's not a variable, then we return a statement. So now let's implement this variable declaration function. And it should have a statement or an error. And let me look at this consume function. Okay, so interestingly, he wants it to return some value. So I guess we will change it. And I think we can call previous, right? Yes. And then return that. And now up in variable declaration, we can say, let's consume an identifier. And then we will say if match token. Then we will assign it to an expression. Otherwise, it has to be the null expression, which I don't think we have. We have a nil here. So, but if it's an expression, we make it just a literal. So we'll say otherwise initializer equals a literal with the value being nil. And then we consume a semicolon. Expected variable declaration. And finally, we will, if everything works, we'll return a new variable with name given by the token and initializer given by the initializer. Okay. Let's check it, see how bad it is. So we have to explicitly, so there's no conflict. And so, okay, we also have to explicitly say that we're trying to make a statement. And now there is a problem. here, line 116, to string. Right. So if it's a variable with some name, then we just say let's do it like this. Should be good. Or we can even say .lexeme, I guess. Didn't like that. Okay, now this one. What is the return type? It's a literal value. Okay, that's a little bit more strange. I'm gonna put it on the top just because this binary thing is so huge. So, can we return a result type here? I guess the problem is you could say that it should evaluate to the value of the variable, but we don't have access to that. So I'm actually gonna make it to do. And now we go into the interpreter. If it is a variable, we also mark it to do. Okay, name initializer. And now we're back to the warnings, I think. Okay. Probably means we'll have to restructure this thing so it also takes an environment, but we'll get back to that. Okay, let's look at the parser again. So we have the variable declaration working, and let's see what's next. Okay, so we need to also fix up the primary, and now let's see. It should be like this. If we match the token type is a var, then we need to advance, and the result will be a variable. Like so. Huh. What am I doing wrong? Okay. Okay, so now we get to environments, which is where we store the value of the variable declaration. So like see it here, if we make a declaration that a equals 1, then that information has to be stored somewhere. And we are going to make a new file, and we will make also the environment struct, which should have a hash map. So we will say value sure is a hash map, and it's a hash map from string to object. That is not great for us. We will say string to literal value. And let's add it to main. And everything seems to be working. So, what next? What's next? So how to store bindings. It uses bare strings for the keys and the tokens. Sure. First, the variable definition binds a new name to a value. Okay. Let's also make the new function. And like that. Then we will take the name, which is a string, and the value, which is a literal value. I think it's called insert. Okay. Great. Okay, so now we need to be able to get values out as well. So that should just be a reference. And you will need to take a name and should return a literal value. And now we can see what happens here. If you get something, returns an option. With a reference. Okay. So really we should write like this. And we will say self the values that get the name. So he throws an error, but we will handle it differently in a different place. Okay, so there is an important point that how you handle this error, what do you do if a name is not defined, will have implications for example, how you define recursive functions like this, because here you can see that this function is referring to something that is only defined later. So if you want to allow this, it should be okay to refer to things that are not defined, but obviously you cannot execute the code. So so the error should be handled probably, at the level of when we try to evaluate the evaluate an undefined expression, but not before. Okay. Now we need to add an environment to the interpreter. And we store it as a field in the interpreter, so the variable stays in memory as long as the interpreter is running. We have 2 new syntax trees, so that's 2 new visit methods. The first is for declaration statements. Right. Okay. I'm not sure what the two new are, but let's see. So this is our equivalent of the visit thing. So if the initializer is not equal to nil, then let's say value, then the value equals the initializer evaluated, and I guess we can do this. Let me see. Yes, it's an expression. Otherwise, value is set to nil. Evaluate. Actually, we don't need to do that, right? Because a literal, not here, but down here, a literal evaluates to itself. So we can just say this is the initializer, and then we should put that thing into the environment. So self environment define, and it should be then the lexeme of the name, which is a string, and the value. Now we may run into some trouble with the ownership of this string. Okay. And then we have to say environment is a new environment. Oops, and it should be evaluate. And there's a bug in the environment. Okay. If the variable has an initializer, we evaluate it. If not, we have another choice to make. We could make it a syntax error by requiring an initializer. We don't do that. We could make it a runtime error. Okay. So now we have this interesting thing where we don't have this visitor pattern, which apparently can do this. But we need to supply an environment if we want to evaluate something. So we need to use the environment over here, and in the evaluate function we need the environment, and when we evaluate a variable, then it should return something. And we need to say, because when we get a variable name, then, and the name is a token, so we need to look at the lexeme. I don't know why I made an extra space. It can either be something, let's call it value, and then we want to return a literal value. Let me check the environment again. No, it already returns a literal value, so we just return the value. If it returns nothing, then we want to return, and actually we want to return an OK value. Then we want to return an error that says this variable is not defined. And actually, let's say has not been declared. And then it should be the lexeme in here. And I think that's it. Okay. It doesn't look very nice, but whatever. Oops. Okay, and now in here, I guess when we evaluate an expression, we need to give the environment. And it doesn't work. Yeah. So it's because when we get something out of the map, it's a reference. Can we do this? Seems that we can. And this guy will just use the same environment. This will use the same environment. This will use the same environment. And let's try again. Now we need to go to the interpreter, line 17. This function I don't think we need even. Just gonna remove it. And now there's an error here. Okay. Cannot move out of a shared reference. Yeah. This is a problem. And here, I guess, let's change it so it's just a reference since it doesn't need anything other than that. Let's check it. Okay. Okay, so I think now we can run it and we can say a equals 2 and b equals 3. Then we can say print a plus b. And there's an infinite loop. Okay, so it looks like there's something wrong when we evaluate. Maybe it's... Let me try something. So let's say print a plus 2. Yeah, so it's somewhere in the parsing, I think. So it's not a declaration. The declarations were fine. It's a statement. And the statement should fall through all the way to the primary, which does advance, assigns to result. Let me do this on print debugging. Huh, interesting. So, but we can say print something, right? Yes, still works. Okay. Maybe it's this consume. So it should be a statement. Ah, interesting. Very interesting. So we go into the statement. It's a print statement. The match token. It should advance. Then we get the expression. But, what if we just try this? No, still. So let's see if it gets the value. I don't think so. Okay. We need to derive debug so we can print it. And Also expression cannot. Yeah, so we never get the value. So we go Okay, so we try to go to expression, which goes into equality, which should go into comparison, which should go into term, which should go into factor, which should go into unary. We should get here. Yeah. And let's print the token. Type at least. Ah. So shouldn't it return an error? So it should hit this branch. Yes. And why isn't that error kind of propagating up? It's because of this. Great. No, that should be fine. So we return an error, we go here. This one should go up. They all go up. This one just returns it. Okay. So what happens is that this will return an error. Ah, okay. So actually, probably we should do synchronize here, right? Let me just remove this for a second. Yeah. Where did he do synchronize? It was like in a weird place. Yeah, like inside the declaration. I think this makes more sense. But anyway, where were we? So we shouldn't, no, not that, please. We shouldn't look for a var token, we should look for an identifier token. And then we do this. I think that's correct. Now we will say a equals 2, b equals 3, Okay, fantastic. We got it to work. And I think that's it for now. We have variables, we can define variables, we have an environment that we use to evaluate expressions. So it's looking pretty good.